Dendrochronology.
Ah! Dendrochronology!
Dendrochronology is the science of dating events, intervals of time, and changes in the environment by studying the rings of growth in trees. The center rings of a tree represent the oldest part of the tree's life, while the outer rings can tell a dendrochronologist about its recent history. If you click on the center of the tree and slide the cursor to its outer rings, you'll see how the tree grows. To try another experiment, click on Factoid's Close button. Diode radio. Carbon dioxide.
The carbon dioxide fire extinguisher. CO2. CO2 later.
You'll need baking soda, vinegar, a match, a candle, a tablespoon, a measuring cup, and a large drinking glass. Put 2 tablespoons of baking soda into the glass. To do this, drag the tablespoon to the box of baking soda, then pour each tablespoon of baking soda into the glass. Now take a match and light the candle. Pour 1/2 cup of vinegar into the drinking glass. To do this, drag the measuring cup to the vinegar.
Look, a chemical reaction. Very interesting. Now, what can we do with it?
Quickly bring the top of the glass to within 2 inches of the candle flame. Be careful to not pour the liquid onto the flame. Adding vinegar to baking soda produces a bubbling gas called carbon dioxide. Carbon dioxide is heavier than the surrounding air. The gas pours out of the glass and onto the candle flame. When that happens, the surrounding oxygen is displaced and the candle goes out. To try another experiment, click on Factoid's Close button. Light bulb. Carbon dioxide fire extinguisher. Carbon dioxide rocket.
Good. You've chosen the carbon dioxide rocket. Prepare for liftoff.
You're going to need baking soda, vinegar, a small-mouthed bottle with a cork, a cup, scissors, a tablespoon, and a funnel. Place the funnel in the bottle. To do this, drag the funnel to the bottle in the center screen. Add 3 tablespoons of baking soda to the bottle. Now place the cork next to the bottle. Quickly pour 1 cup of vinegar into the bottle and then remove the funnel. To do this, drag the measuring cup to the vinegar. Quickly force the cork into the mouth of the bottle. This must be done immediately after you've added the vinegar in order to trap the gas.
Now stand back. I think it's going to go.
A chemical reaction occurs when vinegar and baking soda are mixed together, which produces the gas carbon dioxide. Since all gases expand more rapidly than liquids or solids, the carbon dioxide gas quickly fills the bottle and escapes from the top. Placing a cork in the mouth of the bottle prevents the gas from escaping. However, tremendous pressure builds underneath the cork. the pressure becomes greater than the friction holding the cork in the mouth of the bottle. That pressure forces the cork to pop off. If you'd like, you can make your own paper rocket and glue it to the cork, like Virgil did. To try another experiment, click on Factoid's Close button. Diode radio, two-can experiment.
Excellent! The two-can experiment. This one really comes together. You'll see what I mean.
You'll need a hairdryer, 10 straws, and 2 empty soft drink cans. Place the straws on a flat surface so they are about 1/2 inch apart. To do this, simply drag the straws to the center screen. Place the 2 cans on top of the straws so they are about 4 inches apart. Hold the hairdryer about 4 inches away from the cans and aim the dryer so that its airstream passes between them. Turn the hairdryer on. Be certain it's set on the high setting. This is an illustration of Bernoulli's principle. Bernoulli's principle says that fast-moving air has lower pressure than slow-moving air. The fast-moving airstream between the 2 cans has less pressure than the surrounding slow-moving air. Thus, the higher pressure of the surrounding air pushes the cans together. Bernoulli's principle is important for understanding how airplanes stay aloft. To try another experiment, click on Factoid's Close button. Flashlight. Plastic bag terrarium. Spool and card trick. Atomizer. Magic mirrors. Dancing raisins. Cleaning pennies. Invisible ink. Telegraph. Diode radio. Electromagnet. Light bulb. Dendrochronology. Simple motor. Spool and card trick. Flashlight.
Good choice! The flashlight.
You'll need scissors, an empty paper towel roll, 2 batteries, a mini light bulb, some copper wire, and tape. With the scissors, cut the paper towel roll open along its length. Place the batteries inside the paper towel roll. Line up the batteries so that the positive end of one battery rests against the negative end of the other battery. One battery will have its positive post exposed, the other will have its negative post exposed. Put the light bulb next to the battery. Tape the light bulb to the exposed positive battery post. Thread a length of copper wire against the length of the batteries. Tape one end of the copper wire to the exposed negative post of the batteries. Close up and secure the paper towel roll with tape. Press the unattached end of wire against the side of the light bulb. This will light the bulb. Batteries contain the potential to convert chemical energy into electrical energy. To do this, a metal wire needs to be attached from the negative post to the positive post. Once this connection is made, electrons flow from the negative post to the positive post. The light bulb, however, provides resistance to the flow of electrons. This resistance causes the filament inside the light bulb to heat up and glow. To try another experiment, diode radio. Atomizer.
Terrific! The Atomizer experiment. Just don't use grape juice in front of the white curtains.
You'll need a drinking glass, water, scissors, and a long straw. Cut the straw almost in half. To do this, drag the scissors to the straw in the center screen. Bring the short glass to the straw. Now, fill the glass with water. Place the straw in the glass. Bend the straw 90 degrees.
Let's get Bits to demonstrate what you have to do next. Bits, could you come over here? I need your assistance.
This is an illustration of Bernoulli's principle. Bernoulli's principle says that fast-moving air has lower pressure than slow-moving air. Blowing air quickly across the top of the straw in the water creates low pressure. This low-pressure area must be filled by something, and that something is the water in the glass. To try another experiment, click on Factoid's Close button. Bend the straw. Diode radio, spool and card trick.
Ah, the spool and card trick. I love this one.
You're going to need an empty spool of thread, a 3x5 index card, and a thumbtack. Place a thumbtack in the direct center of the 3x5 card. To do this, drag a thumbtack to the card in the center screen. Place the spool onto the point of the thumbtack. Place your hand over the card and invert the spool so that the card is now underneath the spool. Blow forcefully through the hole on the other side of the spool and remove your hand at the same time. For a demonstration, click on the spool and card in the center screen. This is an illustration of Bernoulli's principle. Bernoulli's principle says that fast-moving air has lower pressure than slow-moving air. Blowing air forcefully through the hole of the spool causes an area of lower pressure between the card and the spool. The outside air surrounding the card has higher pressure and thus pushes the card against the spool. The difference in air pressure is greater than the pull of gravity, which is trying to make the card fall. The thumbtack merely holds the card in place so it doesn't slip off the side of the spool. To try another diode radio, spool and card trick.
Magic mirrors. This is an experiment on which you can reflect and reflect and reflect.
You'll need 2 flat mirrors, tape, and a penny. Now tape the mirrors together with the 2 pieces of tape. Set the mirrors upright facing towards you. Place a penny in front of the mirrors.
How many pennies do you see? I see 3 reflected pennies and 1 real penny. That makes 4. Mr. Announcer, could you explain this to me, please?
A circle has 360 degrees. If you divide the 4 visible pennies into 360, you get 90. This means that the mirrors are at 90 degrees when you see 4 pennies. Click on the mirrors to open them all the way.
You now see 2 pennies, the one reflected and the real penny.
If you divide the 2 visible pennies into 360, you get 180. This means that the mirrors are at 180 degrees when you see 2 pennies. Try this experiment at home. Notice that as you open and close the mirrors, the number of pennies you see changes. Apply the same formula to figure out the inside angle and use a protractor to check your answer. To try another experiment, diode radio, magic mirrors, cleaning pennies.
Get ready for the dancing raisins experiment. You won't hear about this one to the grapevine. Eat your heart out, Fred Astaire.
You'll need baking soda, a clear drinking glass, water, vinegar, raisins, a teaspoon, and a measuring cup. Fill 3/4 of the drinking glass with water. To do this, drag the pitcher of water to the empty glass. Add 1 tablespoon of baking soda to the glass. Don't forget to stir the liquid after adding 1 spoonful of baking soda. Pour 1/3 cup of vinegar into the glass. To do this, drag the measuring cup to the vinegar. Add about 15 raisins to the bubbling mixture in the glass. When an acid, such as vinegar, is mixed with a base, such as baking soda, a chemical reaction occurs. Vinegar and baking soda produce carbon dioxide bubbles which float in water. If enough of these bubbles attach themselves to a raisin, the raisin floats to the surface. Once the raisin reaches the top of the water, the bubbles pop and the raisins sink. This process continues until there are no more carbon dioxide bubbles left to lift the raisins. To try another diode radio. Clean.
Oh boy, it's the cleaning pennies experiment. This is a way to legally launder money, if you know what I mean.
You'll need a lemon, salt, a small jar with a lid, and 3 tarnished pennies. Squeeze as much lemon juice as possible into the jar. To do this, drag the lemon to the center screen. Shake the salt from the salt shaker 4 times into the lemon juice. Place 3 tarnished pennies into the jar. Secure the lid tightly onto the jar.
Bits, we need a little help out here. Great work, Bits. Now let's open the jar and look at our pennies. Amazing! They are clean as a whistle. Mr. Announcer, could you tell us what's happened?
The acid in the lemon juice and the abrasiveness of the salt work together to remove the tarnish from the pennies. This will also work with tarnished nickels, dimes, and on inexpensive jewelry. To try another experiment, diode radio, invisible ink, telegraph.
Ha-ha! The telegraph! I hope I didn't telegraph that idea to you too soon. Tat-tat-tat, dash-dash what?
You'll need a large block of wood, a small block of wood, glue, some nails, bell wire, a 6-volt battery, a doorbell switch, and a metal T. Drag the glue next to the large block of wood. You'll now need to glue the small block of wood onto the larger block of wood. To do this, simply drag the small block of wood next to the larger block. Pound 2 nails halfway into the top of the large block of wood. Position the nails so that they are about 1 inch apart and toward the end of the block. These will act as your connectors. Wrap at least 15 turns of bell wire around one of the nails. When finished, stretch the wire and wrap it 15 turns around the other nail. Attach the negative post of the battery to one end of the bell wire. Attach the doorbell switch to the other end of the bell wire. Attach the other end of the bell wire to the positive post of the battery. Place the base of the metal T on top of the small block of wood. Pound a nail into the base of the metal T to hold it securely in place. The top part of the metal T should be positioned above the nail connectors and should not touch them. Press the doorbell switch and watch the metal T make a connection with the nail connectors. When you press the doorbell switch, electrons are allowed to flow through the wires from the negative post of the battery towards the positive post. Along the way, the electrons must pass through the loop of wire which is coiled around the two nails. The process of electrons passing through a coil of wire surrounding a nail produces a magnetic field. As a result, the magnetic field attracts the metal T so that it strikes the heads of the nails and makes a clicking sound. When you release the doorbell switch, the circuit is broken, and no electrons flow through the wires. As a result, the nails lose their electrically induced magnetism, and the metal T is released. To try another diode radio.
A diode radio? That sounds like a winner to me.
You're going to need magnet wire, bell wire, a wooden dowel, a bent piece of metal, a block of wood, a mica capacitor, a germanium diode, and L brackets. Wrap the magnet wire around a dowel so that the loops are touching each other. Be sure to leave two ends exposed at the opposite ends of the dowel. To do this, drag the magnet wire to the wooden dowel in the center screen. Attach the wooden dowel to the wooden block. Now you need to use the L brackets to attach the wooden dowel to the block. Anchor the L brackets to the block with tacks. Attach the tacks to each wire lead off the dowel. Be sure to pound the tacks only halfway into the block of wood. Place the capacitor at the end of the magnet wire leads. Place the bent metal strip perpendicular to the center of the wooden dowel. Then attach the other end of the capacitor to the bent piece of metal. Loosely tack the bent piece of metal to the wooden block. Place the diode on the right side of the capacitor. Pound a tack halfway into the wooden block next to the diode. Connect a short piece of wire to the tack at the end of the bent piece of metal. Pound a tack halfway into the wooden block next to this short piece of wire. Attach another short piece of wire to the tack on the end of the short piece of metal. Then connect the other end of the wire to the magnet wire lead coming from the left side of the wooden dowel. Attach some bell wire to the left magnet wire tack coming off the dowel rod. Then connect the other end of wire to a piece of metal. This will be your ground wire. Run 50 feet of stripped bell wire from the outside tack, which is holding the capacitor. This will be your antenna to pick up AM signals. Place the headphones next to the end tacks. Attach one lead from the headphones to the end of the diode tack. The other lead should be attached to the end of the bent metal tack. Pound each tack into the block of wood. To do this, click on each tack. Now you're ready to tune your AM radio. Try moving the tuner, which is the bent piece of metal. You should be able to hear radio stations.
We'll be back in a moment with young doctors in...
The antenna of the radio picks up AM signals. The ground wire provides the radio with its power from weak electrical currents in the ground. The bent piece of metal acts as the tuner to pick up the radio signals along the AM band. The capacitor is used to help filter out unwanted random electrical signals. The diode acts as an amplifier and a switch to allow these signals to flow in one direction through the headphones where they can be audibly detected.
If you want to learn more about the radio, check out Marconi in the theater. He is the father of radio. and macaroni is the father of pasta and cheese.
To try another experiment. Diode radio. Simple motor.
The electric motor, this is very energizing.
You'll need a battery, some wire, 2 paper clips, a small bar magnet, and some tape. Wrap the wire around the battery 15 times. To do this, drag the wire to the battery in the center screen. Straighten out one side of each of 2 giant paper clips. Leave the other side looped. To do this, drag both paper clips to the center screen.
Now I will move the batteries into position. Watch very carefully.
Tape the paper clips to the batteries so that one paper clip is taped to the positive pole of one battery while the other paper clip is taped to the negative pole of the other battery. Attach one end of a piece of bell wire to the opposite side of one of the batteries. Then repeat this step with the other piece of wire. Tape these 2 pieces of wire into place. Place the coiled wire in between the paper clips with the lead ends inside the loops. Place the bar magnet by the batteries below the coiled wire. Connect the end wires together to start the motor. Electric motors convert electrical energy into mechanical energy. Mechanical energy is the energy of moving parts, while electrical energy is the flow of electrons. To do this, the coil of wire acts as a temporary magnet due to the electrons moving through the coil. Once this electromagnetic field is set up, the coil both repels and attracts the bar magnet below, causing the coil to spin. To try another experiment, diode radio, conductor tester, light bulb, electromagnet, telegraph, diode radio, invisible ink, floating ping pong ball.
This is super! The plastic bag terrarium experiment. This one is in the bag.
You'll need a plastic bag, a paper towel, some birdseed, tape, water, and a stapler. Place the paper towel inside the plastic bag. To do this, drag the paper towel into the plastic bag. With the paper towel in place, staple the bag across the middle. Sprinkle a handful of birdseed into the top of the bag so the seeds rest on the staples. Tape the top 2 corners of the bag to a window. Pour some water from a pitcher into the bag until the bag has 1 inch of water at its bottom.
Notice the paper towel absorbs water almost immediately.
The water in the plastic bag travels up the paper towel toward the seeds. Plants need water, light, and the stored food inside the seed in order to grow. As the plant grows, the roots travel toward the water source and the stems travel toward light. This is basic plant growth.
Just like your plastic bag, the atmosphere around the Earth holds in the moisture and gases necessary for the cycle of life to continue.
To try another experiment, click on Factoid's close. Dendrochronology, spool and card trick, plant power.
Plant power. Very good. I believe you'll get a rise out of this one.
You're going to need a long-stemmed white flower, 4 cups, 4 different colors of food dye, scissors, and water. Fill each cup 1/2 way with water. To do this, drag the pitcher of water to the cups. Put 10 drops of food dye into each cup. Use a different color for each cup. Bring the flower next to the cups. Take the scissors and cut the flower halfway up its stem. This will give you a total of 4 mini stems protruding from the main stem. Place the 4 stems of the flower so that 1 stem is in each cup.
In about 20 minutes, you'll see something very interesting.
Plants receive water through a process known as capillary action. Water rises from the ground and up through the plant stem for nourishment. Placing food dye in the water marks the progress of the water through the plant. To try another diode radio, conductor tester, light bulb, electromagnet, diode radio, light bulb.
The light bulb experiment. I think you'll find this extremely illuminating.
You're going to need nichrome wire, a baby food jar, a battery, insulated copper wire, a switch, a hammer, a candle, and tape. Using a nail, punch 2 holes through the top of the lid. The holes should be about 1 inch apart. To do this, drag the nail to the jar.
Step 2 is to remove the lid from the jar.
Insert 1 wire into each hole of the lid. Both pieces of 6-inch wire need to be stripped of coating at both ends. The wire should then fit snugly in the holes. Attach the nichrome wire to each stripped end of the insulated wire on the underside of the lid. Place the unlit candle close to the side inside the jar. Place a 6-volt battery beside the jar. Place a switch next to the battery. Connect a wire from the battery to the switch. Place some tape around the wires in the top of the jar to seal off the holes. Lift the lid off of the jar. Take a match and light the candle. Firmly close the lid on the jar as the candle burns. When the candle snuffs out, flip the switch and watch the light bulb light. The concept behind how a light bulb works is the concept of resistance. Tiny electrons travel from the negative post of the battery, through the wires, and back to the positive post of the battery. Along their route, the electron's path is resisted by the piece of nichrome wire. The nichrome wire literally slows the electrons down, which causes the nichrome wire to become hot. As it heats, it glows.
But why the candle?
The candle is used to burn up the oxygen which exists inside the jar. Oxygen chemically reacts with the nichrome wire to make it break quickly. By first removing the oxygen, the nichrome wire will last longer. To try another experiment, diode radio.
Very good. The invisible ink experiment. This experiment is a real lemon, but there's no lemon law against it.
You will need a lemon, a cotton swab, a sheet of white paper, a light bulb, and a bowl. Squeeze as much juice as possible out of the lemon and into the bowl. To do this, drag the lemon to the center screen above the bowl. Put the paper next to the bowl. Now dip the cotton swab into the lemon juice. Remove the saturated swab and write your secret message on the paper. Now turn on the light. To do this, simply click on it. Hold the paper directly over the light bulb. As the light bulb warms the paper and the lemon juice, the pulp of the lemon juice burns and turns brown. The heat produced by the lamp burns the solid particles or pulp in the lemon juice, causing carbon to form. To try another experiment, diode radio. Diode radio. Help. Encyclopedia. Lab. Theater. Activity center. Print shop. Exit.
Imagine what the world would be if there were no discovery. There'd be no electricity, no radio, or no TV. It's true. It could be you. So let's thank all the girls and guys who helped to open up our eyes. It's true. It could be you. It could be you. Our thanks to Daniel Bernoulli, to Madame Pierre Curie, to Leonardo da Vinci, and Julio Marconi. It's true. It could be you. It could be you. To see something before it's there. It's very, very, very rare. It's true. It could be you. It could be you. Knowledge that you can't resist, then you might be a scientist. So make yourself a little list and form your own hypothesis. It's true. You know